Okay, now we're starting video 2. And we're looking at example number 2, similar triangles. Show that a pair of triangles is similar. So we have this triangle here, triangle Q or PRQ, and then this triangle here, KLM. All right, so if you notice, they have different angles. Now, without looking, I could fill these in knowing that similar triangles or figures have the same size angles. However, we want to prove it. So we're going to use the sum of a triangle, which is always, remember, 180 degrees to find R. So let's first start by finding R. We don't know what that is, so let's figure it out. We're going to take 89, angle P, plus 43 degrees, angle Q, plus angle R, and we know it equals 180 degrees. All right, when we add 89 and 43 together, we get 132 degrees. Plus angle R needs to equal 180 degrees. Remember, it's a one-step equation, so we take away this angle if that helps us. Think of it like a one-step. Okay, we have positive 32, so we need to subtract 132 from both sides. So 180 minus 132 degrees. That results in R equaling 48 degrees. So I can go ahead and say this is no longer a variable, but rather 48 degrees. And if I added these all up, 48, 43, and 89, it would equal 180. So we know by kind of rotating this triangle around or looking at the angles that are the same, which in this case is P and L, if P is congruent to L, meaning they're the same, angle L, each measures 89 degrees. Angle R then is going to be congruent to K because we solved for R and it was 48. So that is the same as angle K. So angle K and angle R both measure in at 48 degrees. So triangle PQR is similar to LMK by angle-angle similarity. Okay, now for our quick checks. There's just going to be 2 problems, and you're going to show again that each pair of triangles is similar. I want you to pause the video, try these on your own, and then we'll get started. Okay, let's get started. So, what am I going to have to do first? Well, by the angle sum of a triangle, I know that both of these triangles have to equal 180 degrees. Okay, that's important. So, I can look at this and go and solve for one of the missing angles. Or I can be insightful and see, well, 75 and 75, so I have to solve for one of them. It doesn't matter which one. So I'm going to use these two because that goes there and that one goes there. So 75 plus 75 equals 10, carry the 1, 150 degrees. I have to subtract that from 180. If I subtract that, that is 30 degrees. So I know that angle S is 30 degrees. So since then angle M, or the measure of angle N equals 75 degrees, okay, because it's going to be similar. This one's 30, this one's 30, this one's 75, this one has to be 75. So the measure of angle N is 75. And we know that because, well, angle L is congruent to angle U because they both measure in at 75. And then we can also say that angle N is congruent to angle T because both measure in at 75 degrees. So we can say triangle LMN is similar to triangle UST by angle similarity. Not too hard. Same as our one above. All right, this one's a little trickier because the similar triangles are within each other. So again, I'm personally going to start by solving for our missing angle here. Okay, so I'm going to use our same rule, 180 degrees. So I'm going to take 88 plus 28 and solve for that. That is 116 degrees. Okay, I'm going to take that 116 degrees and subtract it from 180. When I do so, I get 7 minus 1, I get 64 degrees. So I know that this is 64 degrees. I could apply other knowledge I have of like a transversal and same side interior angles to figure this out, but it's safer just to use this. All triangles have to equal 180. So let's look at this here. So by the sum of a triangle, which is 180 degrees, the measure of angle E is going to be 64 degrees. Angle A, okay, so angle A is the same or is congruent to angle E, and they're both equal to 64 degrees. Since we know that this is 64, if I were to extend this, okay, I know that this also has to be 64 angle B because I would have to also apply the triangle sum theorem here as well. And forget about these two measures for a second. And if I go back here, I would say, okay, 64 plus 64 plus 28. Oh, I'm sorry. Back up. We don't know this is 64 yet. So what we're going to do is we're going to add 64 plus 28. That's going to give us 92 degrees. When we subtract that from 180, okay, using our calculator, that is 88 degrees. So actually, I disagree that angle B is 64, which is on my key. It's actually 88. So these are same side interior angles. Okay, so I'm going to go back to what I was saying. The measure of angle E is 64. We found that out using our triangle sum theorem. Angle A is 64 degrees, and that is the same as, or congruent to, angle E, which is 64 degrees. Because these are the same, we know these are the same, So all the angles we have the same measurement, 64, 88, 28, 28, 88, 64. So we know that triangle ABD is similar to triangle ECD by the AA similarity theorem. I apologize for the confusion at the end. If there's any questions, you can come see me or just play it again. Show that we can solve for this one, we can solve for a big triangle, and when we do that, we find that they have corresponding angles that are congruent, and therefore that makes them similar by AA similarity, which stands for angle-angle similarity. All right, that's all. Goodbye.